try. Yeah, sure. I mean, okay, so we need to, first of all, we need to label the information that we got, because there's a lot of stuff up there. And unfortunately, Lamar and Lawrence
Don't make this very easy.
they do not make this very easy. It wouldn't be like Kat and Bella. That'd be way easier. But Lamar and Lawrence, they both start with an L. So what do you want to call Lamar?
LM.
How about one letter? Lamar. Okay, so we're gonna call Lamar M.
And Lawrence W.
No.
Perfect. Lamar is approximately normal. What's the mu for Lamar? Lamar. 105.
And with the standard deviation.
And what's our standard deviation for Lamar?
10 minutes.
10 minutes. Okay. Then over here we got Lawrence. So shall we call him W? Isn't that interesting how like even the first letters that are different in their names are just like the reflection of each other?
Oh. Maybe they're twins.
Oh, maybe. Okay, so for Lawrence, the average time it takes Lawrence is
It's a lot quicker.
98, and the standard deviation for Lawrence is 15 minutes.
Should we draw a,
Not yet, but you are thinking. I like it.
what?
Bella already drew those.
It's okay.
She's ahead of the game.
should try so hard.
Okay, so this question is asking us about how often they finish within 5 minutes of each other. Okay? So I have two separate distributions. Lamar has his own distribution of time it takes. Lawrence has his own distribution of time it takes. What are we going to do with these two distributions in this problem?
Subtract them.
Add them or subtract them?
Isn't that the same thing? Or is that
Mm,
just standard deviation?
that's just for standard deviation.
Um,
So if I want to know, like, I want to think about how often it is that they're finishing within 5 minutes of each other, what do I need to do to their two distributions? Subtract them, right?
Yeah.
Like if I want to know
Oh,
like,
yeah.
the time the time in between when they finish, like let's just say on a random day, Lamar takes 100 minutes and Lawrence takes 80 minutes. Like, am I going to add those and have 100? Did it take 180 minutes, like the whole thing? No, I want to know that Lamar finished 20 minutes earlier than Lawrence, right? That's what I want to do. So we're going to call this D, or whatever letter you want. So D is going to be the difference in their times. So we need to pick. This is super important. Does order matter with subtraction? Yes, so we need to pick an order right now and then stick with it. It doesn't matter which order we do initially, but whatever order we pick, we got to stick with that order. So do you want to do
Lamar minus Lawrence.
Lamar minus Lawrence? So this is going to be the difference it takes them to finish. So again, it doesn't really matter like here which one we pick. But whatever we pick, we want to make sure we're consistent when we do this. So that's why it's a good idea to write this down so we can't forget what we did. Yes, Laura.
Should the L be W?
Oh, yeah. Oh, no. Thanks.
Yeah, Laura.
Thank you, Laura.
Just think of pencil.
Okay. So if I want to find the average time that they finish within each other, right? So if I want to find my mean of D, what do you think we're going to do? Subtract what?
105. 90.
So I'm going to do the average for Lamar minus the average for Lawrence. Okay? Which is going to be 105 minus 98,
LAW.
which is 7. What does that number 7 mean? Like if you had to write a sentence about what 7 means in context of this question, what would you say? Bella?
On average, it takes Lamar 7 minutes longer to do whatever job he has to do than it takes Lawrence to do his
The same
Other
job.
job.
Okay, so on average it takes Lamar 7 minutes longer to
Hello.
finish his work,
Okay.
right? So on average, they're finishing 7 minutes within each other, and Lamar is taking longer. Okay, since we're saying on average, like what does that mean? In many, yeah, right? So. In many trials, in many,
Days.
I'm gonna say trials, I know it's weird. Okay? Okay, now here, for my standard deviation. What am I gonna do for standard deviation when I'm combining two distributions?
The variance.
Square
Square, add, square root, but this is subtraction.
It's the
Square
same
add,
Same thing, square, add, square root. So I'm gonna do this, square my standard deviation for this M guy, I don't know who it is, I can't keep track of these names, right, and do that. Okay, so that means Lamar's was what, 10? And Lawrence's was 15. So it is gonna be 18.03. That's the standard deviation.
225.
So again, on average, it's gonna take Lamar 7 minutes longer to finish his work if you look at many trials. And how much can this vary by?
About 18
About
minutes.
18 minutes each time, right? So, you know, there's gonna be a range. Sometimes Lamar is gonna finish faster, sometimes Lamar is gonna finish slower, but that's what's going on. So now it says, what's the probability that they're finishing within 5 minutes of each other? So now what are we gonna do?
Draw the curve.
Now we're gonna draw our curve, okay? If you drew it earlier, that's great, but we didn't really have the information to label it yet, okay? So now, here's our lovely little
Wow,
curve,
that
right?
was really good.
Wow, look at her.
That is a really
I
nice
love-
curve.
Hey, you guys are so weird.
And they're supposed to be both normal.
Okay, so there's the average time in between them. I wanna
Wow,
know,
it's a perfect line too.
Within 5 minutes.
I wanna know the probability that they're gonna
So-
finish within 5 minutes of each
So
other.
to
So
go
what does
from-
that mean, Kat?
From 2 to 12?
Hmm?
Or would it be minus 2.5 plus 2.5?
Why are you doing 2.5? What
Because
is
they
this?
said 5 minutes. I don't know.
But 5 minutes, you're saying 2.5, that's not 5.
No, I
But
mean
she's
like
saying on
from
either side.
from either side of 7.
But this is, they're finishing, Lamar's finishing 7 minutes longer. Is this even part of it?
No.
No, if this is happening, we
Oh,
don't want
5.
this.
Inverse storm?
No, I don't know that, I don't know the area.
No, it's just not 5.
Okay, so what are the options, okay? So they wanna finish within 5 minutes of each other. Could Lamar finish first?
Yes.
Sure. And he could finish 5 minutes ahead of Lawrence, right? Could Lawrence finish first?
Yes.
And he could finish 5 minutes ahead of the other one. I forgot who I said. I hate that their names are so similar. Okay. So basically, I could do.
Would it be 5?
Let's see. I could do Lamar minus Lawrence, and I could get positive 5. That would be okay. Yes.
Yeah.
But if Lawrence finishes earlier, if I do Lamar minus Lawrence, and he finished earlier, but we still want to be within 5, what would I get?
Negative.
-5, right? So basically, I want to know
Everything below 5.
everything. What? Here's like 20 minutes earlier.
Isn't it everything between
Negative 5 and positive 5, right? I want to know the probability that, what is that, D, that I'm in between 5 and negative 5. Does that make sense? Like, again, you have to think about what this 7 means. This 7 means Lamar finished 7 minutes slower. Okay, so when I subtract them, I get a positive 7. I want to subtract them and either get 5 or -5
or anything in
or
between.
somewhere in between. Because like right in here, they finish at exactly the same time. Is that a possibility?
Can it be
Sure.
less than or equal to?
Since this is normal CDF, doesn't matter.
Oh, no.
So so it could be, sure. Okay. So we're gonna do normal CDF. My lower is gonna be what? -5. My upper is gonna be,
5,
my mu is gonna be,
7,
my standard deviation is gonna be
18.03.
18.03. Ah. What?
Oh, never mind.
You sure?
Yeah, I just need to write down 18.0.
Okay. So,
Do you have to have the calculator to have that app?
you have to purchase this, so no, but you have to purchase this and this is expensive, so,
Oh, so does it come with the calculator?
no,
Oh, it's separate?
it's a separate thing.
I tried doing it once and it didn't work. You have to buy like the whole.
Did I tell you guys, by the way, what I found out what normal PDF means? Were we talking about that in this class?
Yes.
Yeah.
Did I tell you that I found out what it means?
No.
Normal PDF tells you, I mean, I don't think we will ever need this, but it tells you like, if I have this distribution and I wanna know like what the height should be for like, let's say at 10, if I do normal PDF, it would tell me like how tall that should be. Or like, let's say a more probably useful thing to do would be like, I wanna know on my bell curve, like on the y-axis, on my vertical axis, like how high it goes. Normal PDF would give me that. So if you wanted to be like super precise when you're plotting your bell curve. Anyways, so normal CDF. So I'm doing -5 to 5, 7, 18.03. So about 0.203-ish, yeah?
Yeah.
Okay, so what does that mean?
There's a 20% chance they'll finish within.
Yeah, so about 20% of the time, they're gonna finish within 5 minutes of each other, okay? So, there is a 20.3% chance that Lamar and Lawrence, whatever, will finish within 5 minutes of one another. Okay?
Where did you get so for your normal PDF, like the bounds, the lower and upper bounds, where did you get those?
From here. So again, if I take Lamar, which one would we do first? Lamar? If I do Lamar minus Lawrence, if Lamar is finishing, if he's taking longer, but they finish within